I'm going to be repeating this problem in light of the 3 video segments that I made for the chapter 19. This is the third one for the present problem, and I'm not going to use assembly. Everything is going to be done within the same part. So I have to recreate this object basically based on the dimensions that I had before. So let's start with the part file. Okay, the process is exactly what we did before. Right away, save this thing. Desktop, new folder. So this is a hybrid table, single part. I will not be using any planes of symmetry, but on a test, you have to use all applicable planes of symmetry. Okay, why don't I make the block first, just like what I did before. So on that horizontal plane, I will sketch a 2x2 square. Exit, padded in both directions, 2 inches in each direction. Okay, good. And then we're going to go to wireframe and surface design because we want to draw that plate. So wireframe and surface design, on a convenient plane, on that horizontal plane, I will sketch a 5x5 square. This and that. Sorry, this 5 and 5. Okay, exit. Now what you would like to do is to put a surface here, so use a fill if you have a closed surface. There. And now we want to make a hole here, so on that face we will sketch. These are all the steps that are retraced from before, except that all within the same part. And I'm going to project that silhouette. There we are. Exit. Use the saw. So you want it to cancel. I'm going to try it again. Saw. You want to cut. The element to cut is this face, and cutting element is that silhouette that I created. And let's see how it looks like. I think that's good. Should be a hole in the middle. Yeah, right there. Okay. Let me bring this back in the front. And now we're going to create 4 lines here. Notice that these are all within the same part. So point and direction. So the point is this. Direction is Z. Length is reverse that. Length is 5. The legs are 5 inches long. Again. Okay, so there are, instead of doing this in 4 times, there are other ways of doing it, but I will do it the long way. This one, direction Z, other direction, repeat it again. There are easier ways of doing this. Z direction, flip the direction, and the last one is here. Okay, so what is that last one? This is the point. Direction Z. Flip it. Okay, I'm not using any planes of symmetry. Let's make everything, this entire part, out of steel, metal, steel on the entire part. That's done. So now we're going to go, first of all, let me save this thing. File, save management, save as. I made a folder here, single part, hybrid table, single part. Okay, so that. Okay, good. All right, so we're going to go to generative structure analysis. CATIA immediately measures the block in the middle. You can see that. Okay, and then let me hide some of these sketches that we don't want. This sketch and that sketch we don't want. We're going to hide it. All right, good. So let's see now. Shell mesh, black eye. Okay, let me make this a little smaller, 0.2, and give it a thickness. I think that's the thickness we had, and do the measure for the size one by one. It's painful, but you've got to do it. Not that. One by one. So let's do this one first. Let's do the next one, and the next one, and the next one. And these are all circular cross sections, so already everything is set up there, set correct dimension. So we do this. We don't need the orientation point to close it. We do this. The one in the back, and the one on the left. All right. Now, let me change the rendering here. Okay, so now the connections. Create connections between this face. Remember, I did for the second component this edge, etc. But I also told you that it is possible to select that entire face. So because then I don't have to hide it and things like that. So do this thing 4 times. So that's the difference between what I did, segment 2, and what I'm doing now. So that face, second component, the plate. I did that differently in the other one. Side face, second component, the face. And there are some minor differences if you do it this way. As long as you know what you're doing, and as long as you don't make any serious mistake, there are some minor differences, but that is not going to affect our final results. Now, these are going to be fastened. So this is fastened. Next one is fastened. Next one is fastened. And the last one is also fastened. Number 4. Okay, so you see these 4 fastener sides. And finally, I do the connection between these edges. Now, yeah, I don't want to show you anything that I don't want you to use. So let me hide this. You can experiment with it yourself, but this is not the right time right now. Let me hide this connection. Hide the connection. Second component is this. Very good. Let's go around. Another one. These are going to be rigid connections. So hide this. That corner point. Second component. Bring this in the front. Hide this line. Hide this connection. Because otherwise it won't let me pick what's behind it. That corner point. Do it with this guy. Hide the surface. That point. Bring this to the front. Hide the line. Hide this connection. Because I want to select that vertex, it won't let me do that. And that guy is staring at me. And finally, another connection. Hide this. There we are. Second one. Look, I don't want to discourage you from trying things on your own, but make sure that you have done it and it is what you expect. Okay. And these connections, these are all rigid. Okay, so this is distance connection property. This rigid. rigid. Number 7 and 8 are also rigid. These have to be done separately. You cannot do it all at once. Okay, and let's put the load on the top, because this is the entire model, entire block, no symmetry, minus 500 pounds. Alright, hopefully we didn't forget anything. I'm going to run, and I'm pretty sure everything is okay. This is the same as video segment 2, except that using assembly. Oh yeah, I forgot to clamp the bottom of these bars. Okay, so let's do that right now. Clamp this, and that, and that, and that. Okay, now go run it. This was completely hanging in, floating in space otherwise. Alright, here's the deformation. There is a stress. Nothing in beams, because you can't plot stuff in beams. 1 meter stress in beam, and this is the deflection of the yeah. So this is it. I did 3 video segments for chapter 19, 3 video segments for this table problem. Exactly same approach. All right.